Welcome everyone. As I was introduced, I'm Krzysztof Otrębski. I'm working for Ocado Technology, and I will be talking about moving state from actors to separate components. I will use state monad from cat to do it. So I want to make my logic pure, and I want to separate side effect execution from calculating my logic. So let me introduce myself. I'm a software developer. I'm working for Ocado Technology here in Kraków. I'm learning functional programming and Scala. And this talk is side effect of running functional programming reading club at Ocado. So agenda for this talk is, first I'm going to introduce the domain of the project. I have some project which will be refactored. Then we will go into current implementation, and I will show you how it looks like. And then I will start refactoring to move logic to state monad. And also I will change tests, so I will not have to use ACCAD to test my logic. And at the end we'll have time for summary and questions. During this talk, I will not focus on technical details, how state monad is implemented, especially in test library. We will just use it. What I want you to take away from this talk is to understand how you can use state monad in your project, what benefit you will have, not exactly about technical details like implementation. So don't worry if you do not understand every detail of state monad. So domain. Domain of this project is vending machine. Let's assume that we have a vending machine which has normal features like selling products, but besides of it, it will have features like reporting to the owner some events, like there is issue with expiry date of product, or maybe we run out of something. So it will have two types of features, one for user and one for the owner. And we have demo application which is using command line interface, and I will show it later. So interaction with this machine is like every vending machine. So user, pointer here, okay. So user can use this keyboard to select product he wants to buy. He can also insert coin, or maybe he can resign from buying process and withdraw his money. On the other hand, machine can display messages to the user on very small LCD screen. From owner's perspective, messages are sent, let's say, to headquarters. In our case, these messages will be displayed on the screen. So this is application, and let me start it. I hope you can see the front. Okay. So what we have on the screen? So in this square bracket, we have information to the user. So this is emulation of this LCD display. And we have, of course, visualization of our vending machine. So information about our current credit, quantity of products and prices, and some maintenance information. So what we can buy, what we can do, we can, for example, insert, let's say, 5 zlotys, let's say type +5. And the message to the user is displayed on a screen that you have 5 zloty of credit. So what we can do, we can, for example, buy 1 banana, price 1, and we have information that you can collect your banana and take your change. And also we have some functionality for the owner. So if we buy last candy, I will insert some coin, and as you can see, we have only 1 candy, so I will buy it. Let's say product number 1. We have information to the owner that we are short of candy. So two types of features. Okay, so let's go back to the presentation. So architecture of this program, it's pretty simple. We have a user which is interacting with machine, and his interactions are translated to messages, and this message is sent to actor, vending machine actor, which contains few vars and one big receive block. So it's a very fat actor. It contains a lot of state and also a lot of logic. And as a result, for example, if we want to display something to a user, message is sent to user output actor. If you want to report something to the owner, you need to send a message to system reports actor. So this kind of side effects are executed in receive block. Okay, so let's see the code. So let's see first our vending machine actor. So as you can see, it contains few vars. Next var here. And our receive block is huge. We have a lot of cases for every message. Details of logic are not so important here. What is important that, for example, if we are selecting product, if we are able to buy something because we have a credit and there is a product in machine and expiry date is okay, so we are executing side effect. So if you want to, for example, test it, let me show the test. We have to use akka test key for testing this actor. I have a list of test cases. Let's say, for example, that we want to test that application is correctly tracking income. So we have to set up some test probes, create our actor, and we are sending message to actor, and we need to validate that side effect was executed and the side effect was sending message to different actors. And we need to send next message. For example, you are selecting product, you are able to buy it, so we need to validate a few more things, check the state of the actor, and then we are going to buy next thing, and we have to validate that our income was 6 because we have bought 2 things at price 3. So as you can see, tests are a little bit complicated. We are mixing a lot of things here, like we have to introduce internal state of this actor by sending messages, prepare state. If you want to check that income is tracked, we need to buy 2 things. So it's a little bit complicated. So the idea is to implement this functionality in separate class and make it pure functions. And I'm going to approach this in this way that I will have the same set of tests for 2 actors. One will be using pure logic and one will have pure receive block. Just to validate that these 2 implementations are doing exactly the same. And later I will introduce a test only for logic. So we can compare how it, which approach is easier to test. Okay, so let's start with coding. I will use Groll plugin just to move through each commit, so it will be much faster. And let's say that I want to start with implementation of update credit method. So if user inserts some coin or resign from buying, I want to update current credit. And I'm going to approach this with state monad. And question here, what is state monad? So state monad is a function which accepts state current state, and as a result, it will return new state after modification and some effects to execute. These effects are not yet executed, so you have control when you want to execute them. So in our case, I'm passing to this state monad current state of vending machine, and I want to get result new state and maybe some action, for example, some message to be displayed to the user. So I have created update credit method, which takes action, and it should return state monad. And my state is vending machine state, declared below. And as a result, there is option of user output, so some output to the user. And depending what happened, for example, if I insert credit with some value, I'm changing my state. I'm incrementing current credit by this value, and I'm sending message. I want to send message to the user that your credit is updated with current value. So I'm returning object called credit info. It's not yet executed. I want to execute later in my actor code. So execution of side effects is postponed. So I have this function. It's not yet used, but I can check how it behaves in test. So I have already prepared a bunch of tests for my logic. They are not yet implemented, but for update credits, I have implementation. So how I can test it? So let's say that I want to insert 2 and then 5 zlotys. And I can build state monad by composing these two and collect 2 effects. So effect after inserting 1 coin and effect after inserting second coin. And as a result, I will get final state. So I can prepare this monad using for comprehension, and then I will just run it with my initial state and get value. And value is a tuple of state and effects. So I can check now that after inserting 2 and 5, my credit will be 7, and I have 2 messages to the user after insert first coin and after insert second coin. So I can test in the same manner scenario when user wants to cancel process. Okay, so we have implemented one method of inserting coin and resigning from buying. So we can go next and insert next, implement next logic, and it will be selecting product. So I will move to next commit. So what happened here? We have implemented next method, which is creating next state monad. It's called select product. So if user selected product, we have to check if he can buy it, if we have this product, if he has enough of credit. And depending on these values, return new state. For example, if he was able to buy product, we are returning new state with new quantity, and we want to tell the user to please take your product and take your change. If we run out of the stock, we return the same state because nothing changed for this vending machine, but we want to inform user that we cannot sell this product because we run out of stock. But again, these side effects are not yet executed. We have to execute it later. We just return some values. From testing perspective, it's the same. We can write test, build our monad. Let's say we want to buy a beer, and we want to run this monad and get value as the get result, and we can check that income has changed, and our effect is now that we want to tell a user to take your product. And what is interesting here, we don't have to insert any coin in test. We just define that our initial state is vending machine and credit is already there. So we don't have to prepare internal state of our component for testing. Okay, so we have already part of managing his money, selecting product. So maybe we can start with using this logic and making this program a little bit functional. So now I want to use this logic in actor. So what I want to do, I want to compose bigger monad from this 2 or 3. It's additional about displaying state depending if something changed. So I composing this monad using for comprehension and how it behaves. This is state monad, so it behaves in this way that initial state is passed to first method, result is pair of new state and effect. Effect is sent here to the left, and modified state is passed below to next method. And again, effect is passed here on the left as select product, and modified state again is passed below. So the state monad in for comprehension is managing passing modified state through all our steps in this sequence. And in yield section we can build our final effect. It will be some object to aggregate all possible effects. So we can also use this in actor. Check our actor code. So I have created next actor. I want this actor to have the same interface as previous one, but there is small change. For example, we have only one var, and this one var represents whole state of this vending machine. And if I receive some action, I want to take my build monad, compose it. I'm composing it. It's in previous class. I'm running this monad with current state of vending machine, and I want to take value. So as a result, I get new state of this vending machine. I get effects executed. So I can update state. For example, there is quantity of product has changed, or maybe income has changed, and I want to execute side effects. So I'm taking all these messages to the user and sending to different actor, which is responsible to displaying it. This side effect can be also accessing a database or file system, but we have separated running our logic from executing side effects. And you can also check test for our state monad. Okay. So we have tests for our small monads, and we can also take our compose part and run like a business scenario. Like, for example, you want to successfully buy something and check that change was given to the user. So again, I'm using for comprehension. I want to insert 10 zlotys to machine. I want to select product number 1. I want to run this monad, and I want to check state after this action, and state should be that quantity of beer is reduced to 4, and output to the user should be information to take your product and take your change. So I do not have to catch any messages in test probes. I just take values and validate them. We can also run this program. It should be functional. I can choose which actor I want to use. I'm going to choose actor with state monad. So I can insert 5 zlotys and I can buy banana. So there is a message to a user, so everything is okay. Quantity has changed, income has changed, so it looks functional. But we do not have implemented yet functionality for the owner. So if I bought last candy, so there is only information to the user, take your candy, but there is no report to the owner. So we need to still implement more things. So what I'm going to do right now, I will move to the commit where all this technical features for the owner are implemented. So as you can see, our compose method is now much bigger. We have more and more things in for comprehension. I have added additional methods, like for example, detect shortage. If we buy last item, we need to notify user about it. If there is some issue with expiry date, we want to notify him. Maybe there is a lot of money collected in machine and we need to collect it. So more and more logics are implemented below. We can check below that all these methods are implemented. Details are not so important. Important is that this is also state monad accepting the same state and returning some of the result. So again, in this for comprehension, if we run this, state is passed from one state monad to the next one after modification, and we can collect side effects on the left. And after, in a yield section, we can build our final result and return this as a result of our composed state monad. So from actor perspective, almost nothing has changed. What we are doing additionally, we are here. We are sending reports to the owner of this vending machine. So we are executing additional side effects. But invocation of logic is almost the same. We have added only timestamp, because if you want to check expiry date of a product, you need to know what time is it. But our logic do not depend on any time. You just pass current timestamp as an argument. So okay, we can run this again and check that this feature should be now implemented. So after buying last candy, there should be report for owner. Okay, I will insert 5 zlotys and I will buy last candy. Not enough credit. Okay. I have 5 zlotys and I'm selecting candy. So information to the user, it is your candy, and information to the owner, we are short of specific product. So as you can see, we have implemented additional logics, composed in a state monad, and of course we have tests for it. So let me check. All of these test scenarios are now covered. So of course we can run this test and check that everything is okay. So now I'm running test. Okay, to rebuild project. working very well with my IntelliJ. We'll try to rebuild it again, and we'll try to run test. So let's try with command line. So we have 3 test cases, 2 for actors, the same test cases for different implementation, and we have tests for state monad. I'm not able to show you in this view what is important, that if I'm running tests for actors, I need to start actor system, which takes time, this is one thing, and also there is some ugly part in actor test find it. So here's ugly part. So I'm expecting that no message should be received. There is test scenario that no report should be sent to the owner if something happened for a second time. We don't want to inform him again. So in actor approach, what we have to do, we need to validate that no message was received, and we need some timeout. By default, it's 3 seconds. So this one test is adding 3 seconds to test execution. So if you compare time of execution of the test, you have like 3.5 of the seconds compared to 50 milliseconds. So it's a huge difference in time execution. Okay, so this is all from code perspective. Let's move back to presentation. So what happened? So we have this architecture with actor, which contains a lot of logic inside, execution of side effects, and a lot of vars. And we have replaced this actor with a much simpler version, which contains a single object for a state. And this actor is calling logic from separate components. We have used state monad to build small part of business logic and compose it to something bigger. And we can execute this using our actor. And also we can test business logic testing only this component. So this is pure function. It's running very, very fast. And we have no side effects. If you run this twice, you will get the same result. Here, we're testing actor with all this akka test kit framework. The test took much longer. In this case, we have only one test scenario, but if you have more and more tests, your build can be very, very long because of using akka and waiting for no messages to be received. So what benefits do we have of this approach? So first, we have separation of business logic and side effects. So you can run your business logic and return effects to be executed, not execute them yet. So you can validate in test list of side effects. You don't have to catch anything. So you can also compose your logic from smaller parts. We have state in one place, so it's much easier to modify it or change it. And also we have to reason only about pure functions. So our logic is pure function. There is nothing about akka, sending messages, time notification, and so on. From testing perspective, it works very, very fast. So you can, with one test, you can go from seconds to milliseconds. And also you are testing values, not side effects. In akka, received block has is any to unit, so you don't know what will be executed after sending message. So you need to be aware that you should maybe check some messages or check state of database after sending message. We have replaced this with state monad, so we are returning list of effects to be executed, and we can just validate data. So we don't have to mock anything like mocking database, mocking actor references, and also we don't have to set up state of actor during tests. Because you don't have actor, you have just logic, you just say, okay, I have a state of vending machine, and there is like, let's say, credit already inserted, and I want to check what happens if I buy something for a second time. Using akka and actor, you need to run scenario of buying twice. So it also takes time, and your test is much, much bigger. So let me summarize. So what we have done here, we have made our logic in this way that we can compose it. Our logic also is pure, so it's much easier to reason about it and test it. And also our tests are lightning fast. So thank you, this is all from me. If you have any questions, feel free to ask. I have posted a link to this presentation and this project on my Twitter, so there is a handler, and there is also a link to GitHub. So thank you.
I have a question first. I've been in that place and it looks great, but the example is quite convenient in my opinion. What happens if you add some asynchronous dependency to the logic? All vending machines right now has paying method. How do you handle that?
I believe it has to be introduced somehow in your state that you are waiting for something to be received.
You would block inside the state?
I think not. I think not. If for example, you get as result that you want to do some HTTP query to something, to some different service, and you're waiting for results.
Some asynchronous service.
Yes.
For payment method, as an example.
So I believe you should, in your state, say exactly, explicitly, that you are waiting for some response, and when this message will be received, you can process your logic.
But are you aware what you are doing right now? It's a side effect. As
so
you just put into the state. This is a side effect.
Yeah, we are in a process of huge refactoring current in our project.
I was there, and we had huge problem with that. And sometimes you have to go with some, I don't know, go easy, and you have to choose. You are going to as a side effect, and you are splitting it with the external message, and then when you are waiting for the response. But this way you are going into the direction of sagas from DDDs. And you are waiting for response, it takes time, and what happens if other message comes in meantime? It's getting messy.
Yeah,
that's my point.
Yeah, I agree.
Thanks.
But this example, it's more convenient. I think in our project we are in a state when we are executing side effects all around, and this is approach we are going to take. Maybe not exactly state monad will be used, but what we want to do, we want to move our logic to different component, which is not aware of any external word or akka, whatever. We want to have our logic pure. So this is approach we are going to take. And as you said, we will approach the problem you said, and we will have to solve it somehow. We don't know final answer yet, how we are going to solve it.
Thanks for the presentation. I like the idea of separation of concerns, but I'm a bit unsure about the assignment of state back to the variable. So I think one of the ideas was to get rid of the whole state as a variable, but it looks like you just wrapped all the variables into one big variable, and then at some point after all the transformation, you just assign them back wouldn't it be purer to just encapsulate it in monad and then extract it only when it's needed? Like if you go to the definition of the class, for example.
Yes, so as I understand, you're proposing that we can still use many vars in our actor and just compose a state object when passing this to state monad, yes? Did I understand correctly?
Yeah, something like this.
So I think we can do it. It's, I think it depends what do you prefer, a lot of vars, or you have just one var representing a whole state of this vending machine. So I prefer having just one var because it's the same type used in logic and the same type used in actor. So there is no temptation to change some vars just in the fly.
Okay, thanks.
Hello, so first thank you. And I have a question. How would you use this approach in implementing persistent actors? So in your example, you had quite a nice case where you could combine the domain logic of validation and updating the state in a single place. And in the case of persistent actors, you first handle the command, do some validation, and then decide whether to persist an event and update state like in the event handler, so in a other place where you don't have that much of the domain logic, I think.
I believe that in persistent actor, you can just keep execution of side effects if you are recovering. So you know exactly this is my new state and side effects should be already executed, so just skip them.
Right, so it looks like we're done with questions. Let's give our speaker a closing round of applause.
Okay.